Good morning everybody, welcome back to our channel Sri Education. So previous class we learned the 10th class first chapter real numbers, terminating decimals, non-terminating decimals, recurring numbers. So today class is 10th class real numbers first chapter exercise 1.4. So first question, prove that the following are irrational. So here some numbers are given, so these numbers we prove that irrational numbers. So here 1 by root 2 is given, so this is we show that this number is a irrational number. So here first one 1 by root 2 is a irrational, we show that 1 by root 2 is a irrational. So first, before we remember the rational and irrational numbers. So rational numbers means rational numbers means we can write in the form of p by q. Here p comma q are belongs to integers is a rational number definition. And irrational numbers equal to, we cannot write in the form of p by q, where p comma q belongs to integers. So this is the rational and irrational definitions. So now we prove the 1 by root 2 is a irrational number. Already we know that root 2 is a irrational. Already we know that root 2 is a irrational. Root 2 is a irrational. So here we take 1 by root 2. 1 by root 2 equal to, we take here 1 by root 2 is equal to p by q. We say p by q. Here 1 by root 2 is a fraction form. So here p by q, we say that here 1 by root 2 equal to p by q. So here p by q means here root 2 by 1 we write in by cross multiplication, or by cross multiplication q equal to p root 2. So q by p equal to root 2 by 1. So here now 1 by root 2 is a rational number, because here we say the form p by q. So 1 by root 2 is a rational number. So here is a rational number. Suppose 1 by root 2 is a rational number. So here 1 by root 2 is a rational number. Here p by q equal to root 2. Here root 2 is a irrational number. Already we know that root 2 is a irrational number. So p by q is a rational number and irrational number. So this is the contradiction. So here 1 by root 2 is a irrational number. So here p by q equal to root 2 by 1. Suppose here 1 by root 2 is a rational number. So here already we know that 1 by root 2 means p by q is a rational number. Root 2 is a irrational number. So here contradiction. So therefore here root 2 is a rational number and it is a contradiction. So that implies root 2 is a rational number. And it is a contradiction. It is a contradiction. So the contradiction arises due to our supposition that 1 by root 2 is a irrational number. So already we know that root 2 is a irrational number, but here our proof is root 2 is a rational number. So our assumption is wrong. So our assumption is wrong. So therefore 1 by root 2 is an irrational number. So 1 by root 2 is an irrational number. This is our first one proof. Next, second one, root 3 plus root 5. So we show that is a irrational number. So here second one, root 3 plus root 5. So first let us assume is a rational number. Let us assume root 3 plus root 5 is a rational number. So here rational number means p by q form. So we write here root 3 plus root 5 equal to p by q. So both sides apply the squaring on both sides. So square on both sides means here root 3 plus root 5 whole square equal to p square by q square. So this is the a plus b whole square form. So here already we know that a plus b whole square equal to a square plus 2ab plus b square. So here a plus b whole square equal, use this form. Here we write the expansion 3 plus 2 into root 3 into root 5 plus 5 equal to p square by q square. So 5 plus 3 8, 8 plus 2 root 15, 3 5 is 15 equal to p square by q square. So here 2 root 15 equal to p by q minus 8. So here p square by q square minus 8. So here root 15 equal to here root 15, first do the LCM, q square equal to p square minus 8 q square. Here 2 is there, we write here 2. So root 15 equal to here p square minus 8 q square by 2 q square. So this is the p by q form, since this is the p by q form. So p by q form means root 15 is a rational number. P by q form means here root 15 is a rational number. So but already we know that root 15 is a irrational number. So our assumption is wrong. So root 3 plus root 5 is a irrational number. So here this is the p by q form. So here root 15 equal to p square minus 8 q square by 2 q square. So is a rational number. So root 15 is also a rational number. So but it is a contradiction. It is also contradicts. So the fact is root 15 is an irrational. So here root 15 irrational means here root 3 plus root 5 is a irrational number. So assumption is wrong. So our assumption is wrong. What is our assumption? Root 3 plus root 5 is a rational number. So this assumption is wrong means here therefore root 3 plus root 5 is a irrational number. So this is the proof of second one. So here third one 6 plus root 2. So here we prove that 6 plus root 2 is an irrational number. So to prove 6 plus root 2 is an irrational number. So here irrational opposite means rational. So suppose this number we take rational number. So let us suppose that here 6 plus root 2 is a rational number. So rational number means here 6 plus root 2 is a form of p by q. Here q is not equal 0. P comma q are the integers. So here 6 plus root 2 is a rational number, p by q form. So here root 2 equal to here p by q minus 6. So these two also the difference between two rational numbers. So here root 2 equal to here these two are difference. The difference of two rational numbers. So these two difference is equal to rational number. Rational numbers difference to equal to rational numbers. The difference of two rational numbers, this one. So root 2 equal to is difference is equal to rational number. Difference is equal to rational number. Difference is equal to rational number. So means here root 2 is equal to rational number. So here root 2 is equal to rational number. So but we take is a 6 plus root 2 is a rational number. already we know that here root 2 is a rational number is coming, but we know that root 2 is a irrational number. So we know that the fact is root 2 is irrational number. So our assumption is wrong. 6 plus root 2 is a rational number. So our supposition is wrong. So hence the given number is a irrational number. So here hence 6 plus root 2 is a irrational number. Irrational number. So this is the correct statement. So next fourth one, root 5. We prove that root 5 is a irrational number. So to prove that root 5 is a irrational number. Irrational number. So here root 5 is a irrational number. We take the on the contrary, let us the root 5 is a rational number. So on the contrary, let us assume that root 5 is a rational number. Is a rational number. So here we take root 5 is a rational number, is the form of p by q. So here root 5 equal to p by q means we write a by b, and here b is not equal to 0. A comma b are the integers, because root 5 is a rational number. A comma b are the integers. Next here common factor. Here a comma b is a common factor. So common factor, these a comma b are the co-primes. So here where a comma b are the co-primes. Co-primes means here now root 5 equal to a by b, where HCF of a comma b equal to 1, because a comma b are the co-primes. Co-primes means here HCF is 1 equal to 1. So now here root 5 equal to a by b, squaring on both sides. Squaring on both sides. So here root 5 whole square by a square by b square. So 5 square get cancelled. So here 5 equal to a square by b square. So that implies here b carry to left hand side. 5b square equal to a square. So this is the equation 1. 5b square equal to a square. So that means here 5 divides a square and 5 divides a square. So here therefore 5 divides a square, and thereby 5 divides 5. So 5 divides a square and 5 divides 5. 5 divides 5. So 5 divides 5. Now we take a equal to 5c. A equal to 5c. So a equal to 5 divides a means here a equal to, we take a equal to 5c. So now here squaring on both sides. So here squaring on both sides means a square equal to 5 square 25 c square. So squaring on both sides. Squaring on both sides. So here 5 a square. Here first equation a square equal to 5b square. So here write a square place we write 5b square. 5b square equal to 25c square by equation 1. So here we write a square equal to 5b square. 5 1s are 5, 5s are. So here b square equal to 5c square. Here 5 get cancelled. So b square equal to 5c square means here 5 divides b square and b. So here 5 divides b square and b. So that means here 5 divides b square and thereby b. Here b square equal to 5c means here 5 divides b square. 5 divides b square. So here 5 divides a square. So these two are, so first main you observe these two lines. Here 5 divides a square and 5 divides b square. So already we know that HCF is 1. These two are the a comma b are the co-primes. So a comma b are the co-primes, HCF is 1. So here 5 divides a square and 5 divides b square is coming. So this contradicts that a and b are the co-primes. So here contradicts that a and b are co-primes. Already we know that a comma b are the co-primes. So here the contradiction arises due to the assumption is root 5 is a rational number. So here our assumption is root 5 is a rational number is wrong. Root 5 is a irrational number. So here we write that one. So this contradiction arises due to the assumption that root 5 is a rational number. This is our assumption is wrong. So is wrong. So root 5 is a irrational number. So that implies here root 5 is a irrational number. This is our proof. So this is the fourth one proof. First half. Next second half. So here fifth one, 3 plus 2 root 5. So we show that is a irrational number. So to prove here 3 plus 2 root 5 is an irrational number. Irrational number. So here irrational number means we take the contradictory. Let us assume is a rational number. So on the contradictory, let us assume that 3 plus 2 root 5 is a rational number. So now we prove that is a irrational number. So 2 plus root 5 is a 3 plus 2 root 5 is a rational number. So rational number means we write the form 3 plus 2 root 5 equal to p by q. Here q is not equal to 0. Is a rational number general form. So here this one equal to 2 root 5 equal to p by q minus 3. So p by q minus 3. So this equal to we do the LCM q, p minus 3q is the LCM. So here root 5 equal to 2 root 5 equal to this one. So root 5 equal to p minus q by here 2 carry to right hand side, here divided to q. So this is the complete p by q form. P by q form. So p by q form means here root 5 is a rational number. But already we know that root 5 is a irrational number is the fact. Here fact is root 5 is the irrational. So our answer is a p by q form is a rational number. So that is the contradiction. So the 3 plus 2 root 5 is a rational number. We write that one. So here hence here p minus 3q by 2q is a rational number. Is a rational number. Is a rational number means here root 5 is a rational number. Is a root 5 is a rational number because these two are equal. These two are equal means this one is p by q form is a rational number. This equal to root 5. Root 5 is a rational number. Root 5 already we know the fact is root 5 is a irrational number. We know the fact is root 5 is an irrational number. Irrational number. So here root 5 is irrational number. So we write due to our assumption 3 plus root 2 is a irrational number. So here so our assumption is wrong. Our assumption is wrong. What is our assumption? Here 3 plus 2 root 5 is a rational number, is wrong. So this wrong means here 3 plus 2 root 5 is a irrational number. So our assumption is wrong. So our assumption 3 plus 2 root 5 is a rational number. Rational. This is our assumption. This one is wrong. Means therefore here 3 plus 2 root 5 is a irrational number. Irrational number. So this is the fifth one proof. Next, second one, prove that root p plus root q is an irrational number where p comma q are the primes. P comma q are the prime numbers. So we prove that root p plus root q is an irrational number. So here first, here root p plus root q is an irrational number. Here where p comma q are primes. So here given that p comma q are the primes. P comma q are the primes. So here p comma q are the primes means root p and root q are the irrational number. So p comma q are the primes means, so here hence root p and root q are the irrational numbers. So here suppose here root 2 is a irrational number. Here 2 is a prime. Root 3, root 5, these are all the irrational numbers. Here inside numbers is 2, 3, 5 are the prime numbers. So same here p comma q are the primes. Primes means here root p and root q are the irrational numbers. So irrational numbers, so here p comma q are the primes means here p comma q are the no common factors. So p comma q are the no common factors. So here therefore p comma q have no common factors other than 1. Other than 1. So these two are no common factors because these two are the prime numbers other than 1. So they are the p comma q are the prime numbers. So here p comma q are prime numbers. Prime numbers, already we know that. So here now we take p, now we take root p plus root q. So sum is equal to, so here root p and q are the irrational numbers. So irrational number sum is equal to irrational number. So p and q are the irrational numbers. So irrational number sum is equal to an irrational number. So sum of two irrational numbers. So sum of two irrational numbers equal to an irrational number. So hence proved. Here asking p plus q is an irrational. So here hence proved. So here we have to prove that sum of two irrational numbers is irrational number. So here root p plus root q is an irrational number. Irrational number. So this is the proof of second one. So this is the last problem of in this exercise. Complete notes PDF link on description is there. Suppose if you are needed, download it.